Hello everyone, and welcome to this theory recording on the step response of an RC circuit. So what would the step response of an RC circuit be? So from the previous theory, we are aware that an RC circuit has a resistor and has a capacitor, such that you have a first order differential equation that comes out of this, therefore defining it as a first order differential circuit. So this is definitely a first order differential circuit, but it also has a source that is then connected to it, which is what defines the term step response. It occurs when a source is suddenly introduced such that there is a forced response as well as a natural response in the circuit. So a source is present when t is greater than or equal to 0. So the change is actually introducing the source, and there will be a forced response. The forced response is the response coming from the source, and the natural response is the natural response of the capacitor if the source would have not been there. Again, this will be a voltage response. We have a capacitor, so we think capacitor, we think voltage, so we're going to be evaluating the voltage of that particular expression. How are we going to do this? Similar to what we did with the source-free RC circuit. So we're going to say the current going into this terminal will be the same as the current going out. So we're going to say the current going in is going to be Vs minus, we call this point here V over R, and that's going to give you the current IC, which we know is C dV dt. Right, we've got our first order differential equation, and the next thing will then just be for us to cross multiply and then get to similar factors such that it's the rate of change of the voltage with respect to V. We apply ln and we continue to simplify the expression to then result in a final expression that will be as follows. Vt is equal to V0 when t is smaller than 0, that will be the initial voltage, and then when t is greater than 0, Vt will equal to Vs plus V0 minus Vs e to the minus t over tau, where Vs is your steady state voltage, meaning the voltage at time t is equals to infinity. V0 we know is the initial voltage, and minus Vs e to the minus t over tau. Tau is still expressed as the time constant, we know, so tau is equals to Rc. So this is then our final equation that we'll be looking at. V as a function of time will give you V infinity plus V0 minus V infinity e to the negative t over tau. That's when t is greater than 0, and any point in time where t is smaller than 0, V will equal to V0. So the procedure when dealing with the step response of RC circuits: determine the initial voltage. So the voltage at t equal to 0 negative, which is equals to the voltage at t equals 0 positive, and that's going to give us V0. Step 2, determine the time constant. Back to step 1, before we get to step 2, we also have to determine the final conditions. The final condition is V of infinity. So what is the voltage at time t is equals to infinity? So what's worth remembering, which is applicable also with your with your source-free RC and RL circuits, is remember that under DC conditions, which means initially and at time t is equals to infinity, your capacitor must become an open circuit, and your inductor must become a short circuit. Right, second step, determine the time constant. You'll remember that tau is equals to Rc. And then finally you determine your voltage response. The voltage response given by V infinity plus V0 minus V infinity e to the negative t over tau in volts. Thank you for watching this video and enjoy the course.